This is question number 5 of exercise 2.2 class 10 mathematics. Let us go through the question once. If alpha and beta are the zeros of the polynomial 2x squared minus 5x plus 7, then find a quadratic polynomial whose zeros are 3 alpha plus 4 beta and 4 alpha plus 3 beta. So as we can see here in these questions, a quadratic polynomial is given, which is this one, 2x squared minus 5x plus 7, and the question is telling us to find out another quadratic polynomial whose zeros are this one and this one, that is 3 alpha plus 4 beta and 4 alpha plus 3 beta. So how we are going to solve this problem is, since a quadratic polynomial is already given here, we are supposed to use the information given in this particular quadratic polynomial. So let's say given quadratic polynomial is is 2x squared minus 5x plus 7. Now this is our quadratic polynomial which is given here in the question. Now if we compare this with the standard form, comparing this equation, this polynomial with ax squared plus bx plus c, we get a is equal to 2, b is equal to minus 5, and c is equal to 7. The zeros of these two quadratic polynomials are given as alpha and beta. So we're going to use sum of the zeros is equal to minus b by a. Now this is the formula that we have. Now this sum of the zeros, this will be alpha plus beta minus b by a. So sum of the zeros is equal to minus b by a, and so minus b is minus 5, a is 2. Now minus minus is plus, so we got here alpha plus beta is equal to 5 by 2. Now also we know that product of the zeros is c by a. Product of the zeros is equal to c by a. So since our two zeros are given as alpha and beta, so product of the zeros is going to be alpha into beta, and it is c by a. Now c is 7, a is 2. Now we have alpha plus beta is equal to 5 by 2, alpha beta is equal to 7 by 2. Now this is the information that we can get from this given conditions. And now to find the new quadratic polynomial, we're going to find the sum and product of for that new quadratic polynomial. So let's say for the new quadratic polynomial to be formed, new quadratic polynomial to be formed, sum of the zeros is equal to, so for the new quadratic polynomial, the two zeros are this one, 3 alpha plus 4 beta, and this one, 4 alpha plus 3 beta. So when we say sum of the zeros, we're going to add these two given zeros. So it's 3 alpha plus 4 beta plus 4 alpha plus 3 beta. Now 3 alpha plus 4 alpha, we get here 7 alpha, plus 4 beta plus 3 beta, we get here 7 beta. Now we can take 7 common. So taking 7 common, we get alpha plus beta. Now this is equal to 7 into this alpha beta. This is nothing but 5 by 2. So 5 by 2. So 7 5s are 35 by 2. Now this is sum of the zeros for the new quadratic polynomial. Now what we're going to do is we're going to find the product of the zeros for this new quadratic polynomial. Product of the zeros is equal to 3 alpha plus 4 beta into 4 alpha plus 3 beta. Now this is equal to 3 4s are 12 alpha square plus is plus 3 3s are 9 alpha beta plus 4 4s are 16 alpha beta plus 4 3s are 12 beta square. Now here this alpha square and beta square, I'm going to write together here, 12 alpha square plus 12 beta square plus, now this 9 alpha beta and 16 alpha beta, these are like terms, so 9 plus 16, we get here 25 alpha beta. Now again from this 2 we can take 12 common, so let us take 12 common, alpha square plus beta square, and we get here 25 alpha beta. Now we have alpha plus beta, but we don't have alpha square plus beta square. So in order to try to get alpha plus beta, we're going to apply this formula. Okay, the formula is a square plus b square is equal to a plus b holding square minus twice ab. Now I will show you how we get this formula. It's a very simple one. So the formula that you have been using is a plus b holding square is equal to a square plus twice ab plus b square. Now what we're going to do here now is we're going to transpose this to ab to the left hand side. So now what we get here is plus become minus, so we get here twice ab is equal to a square plus b square. So this is our formula. A square plus b square is equal to a plus b holding square minus twice ab. So this is the formula that we have here. A square plus b square is equal to a plus b holding square minus twice ab. So here 12. Now alpha square plus beta square will be alpha plus beta holding square minus twice alpha beta, and then plus 25 alpha beta here. Now this is equal to, again let's multiply both this term with 12. So 12 into alpha plus beta holding square is 12 alpha plus beta holding square minus 12 2s are 24 alpha beta plus 25 alpha beta. Now this is alpha plus beta holding square plus, so we will get here alpha beta. 25 minus 24 is 1. Now we can substitute the value of alpha plus beta. Alpha plus beta alpha plus beta is 5 by 2 and alpha beta is 7 by 2. So we're going to substitute that value here. So this is 5 by 2 holding square, this square, plus alpha beta is again 7 by 2. Now this gives us 12 into 5 square is 25, 2 square is 4, plus 7 by 2. Now here we can cut 4 ones are 4, 4 threes are 12, and now 3 into 25 we get here 75 plus 7 by 2. Now we will take LCM. So LCM is 2. 2 into 75 is 2 5s are 10, 2 7s are here 150. 2 into 75 plus we get here 7. So we have now 157 by 2. So this is the product of the zeros for the new quadratic polynomial. Now that we have the sum and product of the zeros, now we're going to use this formula k x square minus sum of the zeros x plus product of the zeros. Now this k is a non-zero real number, so this k cannot be 0, because if k is 0 then this whole thing becomes 0. So in that case we wouldn't be able to get any quadratic polynomial. So now the required quadratic polynomial is x square minus sum of the zeros. Our sum of the zeros is 35 by 2 x plus product of the zeros, which is 157 by 2. Now this we can take LCM here. So now here we're going to get 2x square minus 35x plus 157. Now this k, if it is equal to 2, then 2 and 2 will be cancelled, and then we will be getting here 2x square minus 35x plus 157. Now here we're taking k is equal to 2. So if k is equal to 2, then we get this as the required quadratic polynomial. Now let's move on to the next question, that is question number 6. If root 5 and minus root 5 are two zeros of the polynomial x cubed plus 3x squared minus 5x minus 15, find the third zero. Now in this question we have a polynomial whose degree is 3, that is the highest power is 3. So since the degree of this polynomial is 3, there is going to be 3 zeros. Then out of that 3 zeros, 2 are already given here, which is root 5 and minus root 5. Now we are supposed to find the third zero. Now before we start the solution, let us recall what you have learned earlier. Zeros of the polynomial is nothing but the values of x for which this polynomial becomes 0. So here the values of x which is given are x is equal to root 5 and x is equal to minus root 5. Now which follows that x minus root 5 will exactly divide this one, which means x minus root 5, this will be a factor of this polynomial. Also here in this case x plus root 5 this will be again a factor of this polynomial. So keeping in mind this thing, we're going to solve the solution. So here solution, the given polynomial is px is equal to x cube plus 3x square minus 5x minus 15, and the given zeros are are root 5 and minus root 5. So as I have explained just now, since root 5 and minus root 5 are its zeros, so this x minus root 5 and x plus root 5 are the factors of this given polynomial, are its factors. So now next step, what we do is we're going to multiply these two factors, x root 5 into x minus root 5 into x plus root 5. This is equal to, now again this is in the form a minus b, a plus b, so I'm going to apply a square minus b square, so that is x square minus root 5 holding square. Now here I'm applying this formula, a plus b, a minus b, which is a shortcut of multiplication. So this is a square minus b square. Now this is x square minus 5. Root 5 holding square is 5. Now what we will do now is we will divide this given polynomial by this x square minus 5, x cube plus 3x square minus 5x minus 15. Now while dividing, you have to first check the first terms of the divisor and the dividend here. So here in this case x square, here it is x cube. So to get x cube you have to write here x. So now we have here x, so x is to be multiplied by this as well as this. So x into x square, you get here x cube. Again you're going to multiply these two, so minus plus is minus, so 5 into x is going to be 5x. So since it is since there is no square here, so we're going to write here in this line. So 5 into x is 5x. Now while subtracting, the sign which is down here is taken to be opposite. So this is plus, so it's going to be taken as minus, and this is minus, so it's going to be taken as plus. Now we cancel this, cut this, this reduces to 0. Plus minus is minus, so x cube minus x cube is 0. Minus plus is minus, so 5x minus 5x is 0. Now we have here 3x square minus 15. Okay, now we have here 3x square minus 15. So to get this 3x square again, I'm going to write here plus 3. So now if I multiply x square and 3, I will get here 3x square. So x square into 3 is 3x square, and I have to multiply with 5 again, this 3 and 5. So minus plus is minus, 5 3s are 15. So this is plus, so it will be taken as minus. This is minus, so it will be taken as plus, so now we get here 0, we get here 0. So finally our polynomial can be written as this multiplied by this, so x square minus 5 into x plus 3. Now this is the factor form of the given polynomial. Now since we're going to find the zeros, so for any zeros of x of the polynomial, this given polynomial should be reduced to 0. Now our polynomial is x square minus 5 and x plus 3 is equal to 0. Now when two numbers are multiplied and if the product is 0, then either one of them is 0 or both of them are 0. So if a into b is equal to 0, then either a is equal to 0 or b is equal to 0, or both a and b are equal to 0. So we are going to apply that principle here. So therefore x square minus 5 is equal to 0, or x plus 3 is equal to 0. So we get here x square is equal to 5, and here we get here x is equal to minus 3. Now this gives us x is equal to plus minus root 5, and another one is x is equal to minus 3. So since plus root 5 and minus root 5 are already given, the third zero that we are asked to find is this minus 3. So here we say, therefore the third zero of the given polynomial, that is bx, is minus 3. So this is our answer.